Hello, so today we're going to talk about verifying trig identities and simplifying trig expressions. And as we talked about the other day, we're sort of moving from solving equations, and so an equation is a situation like this where you've got a variable and you're trying to figure out what values of the variable make the equation true. So here's a quadratic equation. We could try to factor it. We could try to use the quadratic formula, trying to figure out what values of x make that equation true. An example of a simple identity dealing with quadratics would be some sort of expression that's equal to another expression. So x minus 3 times x plus 1 is equal to x squared minus 2x minus 3. This is an identity because this is true for all values of x. And of course, in algebra, we like moving back and forth between these two expressions, depending on what we're using it for. And it's the same thing with trig identities. We're moving back and forth between two things that are the same, and we just want to move from one representation to the other, oftentimes moving from a more complicated thing to a more simplified thing. One of the strategies that's going to come up a lot on these problems is using the sort of definitions of tangent, cotangent, secant, and cosecant. We can get those things in terms of sine and cosine, and then do some algebraic simplification, and oftentimes that's all it takes to do a problem. And so you definitely need to have these things memorized. If you don't already, make sure you're on top of those. If you have these wrong, it can make these problems very difficult. So here's an example. We want to simplify, or we want to verify that secant of x times cotangent of x equals cosecant of x. So the sort of nice thing about these problems is they're basically telling you this is true, and you just have to come up with a way to verify or demonstrate that it's true by going through algebraic steps. And in this case, we see lots of trig functions but no sines and cosines, and so sometimes it's useful to just take our definitions and turn them into sines and cosines. So secant is 1 over cosine, cotangent is cosine over sine. And when I do that, I now realize that, oh, I've got a cosine on top here, a cosine on top here, and so those cancel. And when those cancel, I'm left with just a 1 on the top, and on the bottom I'm left with just sine. And of course this is nice because now I say, oh, well, 1 over sine is cosecant of x. And so I took what was given on the left, I went through some algebraic steps, and I ended up where I was supposed to be on the right. So I have verified that those two things are equal. So just make a little note that it's okay. I'm verified, right? Now I can take that slightly more complicated expression on the left and turn it into that expression on the right whenever I need to. Another strategy, sort of similar to the last one, is to use some fundamental identities, particularly the Pythagorean identities, which we talked about the other day. Remember, the main one is this first one, sine squared of x plus cosine squared of x equals 1. You can get the other two by dividing through by sine squared or cosine squared. And then also remember that you can take any of these, like the second one, and you can rearrange them by subtracting things over. So tangent squared of x equals secant squared of x minus 1. Or you could see in the bottom one that 1 is equal to cosecant squared of x minus cotangent squared of x. And we'll make use of these when we're verifying lots of identities. So here's another one. Again, we want to verify this is true. And so we will sort of think about what to do. The left-hand side is the more complicated one, and I see that tangent there, so we can go back to our first strategy of saying, well, let's try turning the tangent into sine over cosine. And now we've got this sort of complicated thing, and the question is, how can I combine them? I know the right side is just a single term, so I have to somehow combine this sort of mess into one thing, and the first term is a fraction, and so I'm going to take the second one, sort of think about it as a fraction, and I'm going to get a common denominator, and the common denominator is just going to be cosine, because that's what the denominator was over here. And so now I've got two fractions. They both have a denominator of cosine, and so I'm going to have a big fraction with a denominator of cosine. What's in my first fraction? Well, sine times sine is sine squared. And in my second fraction I have cosine times cosine, which is cosine squared. And now, hopefully, this sort of jumps out at me. I have sine squared of x plus cosine squared of x. That's one of my main Pythagorean identities. That is equal to 1. And so that cleans up very nicely. I end up with 1 over cosine of x. And, of course, 1 over cosine of x is, by definition, what secant of x is. That's just what I was aiming for. So, again, I took this complicated thing, went through some algebraic steps, ended up on this right side, and so I verified it, right? This is okay. This is one of those things where maybe the steps look sort of easy. The question is, how do you come up with those steps? And unfortunately, the answer is just lots of practice and thinking about general strategies. And so, a couple strategies that we've been working with here on the last couple of problems. Generally, it's easier to work on the more complicated side first because there's more stuff to do there. If we go back to this one, and if I tried working with secant of x, there's not really a lot I can do with secant of x. I mean, I know it's 1 over cosine, but that's about it. There's definitely a lot more things to do on the left-hand side. And then another strategy we just used is if you have a couple different fractions, you can combine them by getting a common denominator. And sometimes you also see problems where you have a single fraction and you can break it into two terms. And what I mean by that, just in sort of a simple example, if you have a plus b over c, sometimes it's actually useful to break it into a over c plus b over c. It's sort of the opposite of what we just did. And so you'll see that strategy come up in a homework problem or two, I'm sure. Another strategy is sometimes it's useful to work on both sides separately if the two sides seem sort of complicated. And so in this case, both sides seem, like I said, sort of complicated, and so we can try and work on both of them if necessary and sort of meet in the middle. And so in this case, on the left side, I've got two fractions. They both have cosine in them, so I can't really reduce it into other trig functions. But I do see two fractions, and so I can try to get a common denominator. And so the common denominator on this one is going to be the product of those two denominators. So right here I'm going to multiply by the other denominator, so 1 minus cosine over 1, oops, that's a minus 1 minus cosine of x. And on this one I'm going to multiply by 1 plus cosine of x over 1 plus cosine of x. And so on that left side I'm going to have this big fraction, and the new denominator is going to be 1 minus cosine of x times 1 plus cosine of x. And on the top I'm going to have 1 minus cosine of x plus 1 plus cosine of x. Okay. And so this is a bit messy, but it can be simplified quite a bit. In particular, up on the top, I see I have a minus cosine of x plus cosine of x, and so those are going to be canceled. And so the top is just going to be 2. And then on the bottom, I have to FOIL, and so I have 1 times 1 is 1. And then I get minus cosine of x here and plus cosine of x here, and so those cancel, which is nice. And then I have minus cosine times cosine, so I get minus cosine squared of x. Well, that's pretty good. And again, as you do these, you start to recognize some things. Like I see 1 minus cosine squared of x. If I go back here a little ways, that should remind me of this fundamental identity with just one of the trig functions moved over. So if I jump back here, 1 minus cosine of squared of x is sine squared of x. And so I end up with 2 over sine squared of x. And sine on the bottom is 2 cosecant squared of x. And so this is pretty simplified. I mean, if we sort of imagine I started with these messy fractions, and now I've got 2 cosine squared of, or cosecant squared of x, which unfortunately is not what I was aiming for. I was aiming for 2 plus 2 cotangent of x. And so now what do I do with that? Well, now I see if I can work on that right-hand side. And so I've got 2 plus 2 cotangent squared of x. and I try and do some simplifying. And in this case, those 2's are sort of annoying. I don't have any basic identities with a 2, and so I'm going to try factoring out that 2. When I factor out that 2, I'm left with 1 plus cotangent squared of x. And again, when you see a 1 and a trig function squared, you should be thinking about these fundamental identities. And sure enough, back here I see 1 plus cotangent squared of x is, conveniently enough, equal to cosecant squared of x. And so I end up with 2 cosecant squared of x, which, if you remember, back here I had started with the left-hand side, did quite a bit of work, ended up with 2 cosecant squared of x. Now I took the right-hand side and did just a little bit of work, and I ended up with 2 cosecant squared of x. And so I worked on the left side, worked on the right side, and I sort of met in the middle, and the middle was 2 cosecant squared of x. I simplified the left side into that, I simplified the right side into that, so they must both be actually equal to each other, and so I'm okay. Those two things, those two expressions that I started with are equal, and they're actually both equal to 2 cosecant squared of x, which is the simplest of all the 3 expressions in my opinion, but they are all 3 equal. So, as I said, these problems take lots of practice and just keeping the strategies in mind, and don't feel bad if you get stuck and you have to try something else or ask for a little help, but the main thing is you have to actually do these problems instead of just watching someone else. And so here are a couple you can try in your notes. I'm going to give you a second to pause the video, try these, see how far you can get, and then start up the video again, and I'll show you or at least one way to do these. There are often more than one way to do these problems. So please pause the video now. Okay, so we are back, and we're going to talk about how to do cosine of x times cotangent of x plus sine of x equals cosecant of x. And so I'm going to take this left-hand side, cosine of x, cotangent of x plus sine of x, and try and simplify it. So cosine of x times cotangent of x plus sine of x. And this is sort of similar to the first one we did on the video. I'm going to take that cotangent of x and realize that I can rewrite it in terms of cosine and sine. And now I've got these two things that I can add together. If I get a common denominator, the common denominator is going to be sine. So I'm going to multiply top and bottom by sine. And now that I've multiplied them, or now that I've got that common denominator, I can combine them into one big fraction with sine on the bottom. Over here on the top, I've got cosine times cosine, which we write as cosine squared. Over here, I've got sine times sine, which is sine squared. And now, sure enough, I recognize that Pythagorean identity, the top cleans up to 1. I get 1 over sine of x, and 1 over sine of x is cosecant of x. I go back and check. Sure enough, that's what I was aiming for. So I took the left-hand side, simplified it into the right-hand side, and so that identity has been verified. So I'm okay. Next one, sine of x over 1 plus cosine of x plus 1 over 1 plus cosine of x over sine of x equals 2 cosecant of x. And so left side definitely more complicated. I'm going to try and combine them. They're already in terms of sine and cosine, and so I'm going to start by getting a common denominator. And so I'm going to take this first fraction and multiply by the denominator of the other one, so sine of x over sine of x. And here I'm going to multiply by 1 plus cosine of x over 1 plus cosine of x. And I'm now going to have one big fraction, and the denominator is the product of those old denominators, so sine of x times 1 plus cosine of x. And on the top I have to multiply, and so I'm going to get sine of x times sine of x, which is sine squared of x. And here I'm going to get 1 plus cosine of x times 1 plus cosine of x. And so that's a FOIL problem. I'm going to get a 1. And then I'm going to get 2 cosine of x. If you're not sure of this, make sure you're writing out the FOIL steps. And then I'm going to get cosine squared of x. Okay. Again, as you do these, things will start to jump out at you. In particular, in this case, what hopefully is jumping out at you is I've got a sine squared plus a cosine squared. And so those two things are going to simplify via the Pythagorean identity to 1. And so I'm going to have 1 plus 2 cosine of x on the top. So if I jump ahead to a slide here, I'm going to have 1 plus 2 cosine of x. And my denominator, remember, was sine of x times 1 plus cosine of x. So sine of x times 1 plus cosine of x. And there's just a little more simplifying I can do. 1 plus 1, of course, is 2. And now sometimes people get to this point and they're not quite sure what to do. It's helpful to think about the goal. The goal was we're trying to simplify this big mess into 2 cosecant of x. Well, of course, 2 cosecant of x is like 2 over sine of x. And so I see this sign on the bottom. And so I see this sine of x on the bottom, which is good, and that means I want to get rid of the 1 plus cosine of x. And the way I can do that is I can factor out a 2 on the top. And when I do that, it's very nice because I now see a 1 plus cosine of x and a 1 plus cosine of x in the top and the bottom. I can cross out this, and I'm left with 2 over the sine of x. But of course 2 over the sine of x is just what I was looking for, 2 cosecant of x. And again, back here, that is what I was trying to simplify. And so this big messy fraction is actually just 2 cosecant of x. And it's sort of fun if you haven't done this yet. Graph the left-hand side on your calculator, graph the right-hand side on your calculator, and you'll see that those two things really are equal. I have verified that trig identity. So hopefully you have seen some good strategies here, but as I said earlier, it's really all about practicing them on your own, trying few things. Sometimes you get stuck and you have to start over, but it's definitely one of those things you get better at with practice. Thanks for listening.